Hello there, and a massive welcome to all you Primary 7 candidates joining us today. We're diving straight into this explainer, and we're talking about whole numbers. Specifically, we're going to master massive numbers together. By the time we're done here, you'll be looking at huge, intimidating numbers and knowing exactly how to break them apart, read them, and write them like an absolute pro. So go ahead and grab your pen and your exercise book, because we're going to make this fun and incredibly easy to understand. Let's get to it. So, I've just got to ask you right off the bat, are you ready for the ultimate big number challenge? Take a look at that 8-digit number right there, 99,999,999. I know, it looks giant, doesn't it? But seriously, don't worry, I promise you, once you get the hang of the simple rules we're covering today, reading, writing, and expanding a number this big is going to be as easy as counting to 10. All right, let's jump right into part 1. Place value versus actual value. Now, this is a super common area where students get tripped up on exams. Think about this for a second. When an examiner asks you for the place value of a digit, and then turns around and asks for the actual value of that exact same digit, what do those two similar sounding terms actually mean? If you've got your notebook handy, quickly jot down what you think the difference is. Let's see if you're right. Okay, here's the answer. The place value is literally just the name of the position where the digit lives. Think of it kind of like the name of the house the number lives in, right? Like 10,000s or millions. It's a word. But the actual value, or sometimes just called value, is how much that digit is truly worth in numbers. So if a 4 lives in the 10,000s house, its actual value is 40,000. So remember, place value is the name, actual value is the total amount. Let's look at this place value chart. Starting all the way over on the right, we've got our ones, then tens, and hundreds. That's the basic group we all know. But as we move left, man, the numbers get massive. We enter the thousands family, thousands, 10,000s, and 100,000s. And finally, for our really big 8-digit numbers, we step into the millions family, millions and 10 millions. Getting comfortable with this chart is basically the master key to everything we're doing today. Let's test this out right now with a quick question pulled straight from our Primary 7 study materials. Look at the number 49,647. I want you to focus just on the digit 9. What is the place value of that 9? Remember, I'm asking for the name of the position it's sitting in. Go ahead and count from the right if you need to. Did you get it? The 9 is sitting in the 4th spot from the right, so the place value is thousands. Simple, right? But wait, what if the exam asks for the actual value? Well, because that 9 is sitting in the thousands position, we just multiply 9 by 1,000. So the actual value is 9,000. See how easy that is? You literally just aced one of the most common exam questions out there. Okay, moving right along to part 2, writing numbers in words. So it's one thing to understand the numbers, but we've also got to know how to correctly say and write these massive numbers in English. And we have a really simple 4-step game for this. Step 1. Always start from the right and group the numbers in threes using commas. Seriously, those commas are your best friends. Step 2, read the group furthest to the left first and name the millions. Step 3, move to the next group and name the thousands. And step 4, just name the rest of the numbers exactly as you normally would, hundreds, tens, and ones. If you use your commas, the number will practically read itself. Now that we know how to read them, I've got another question for you. What happens when we pull a complete, solid number apart into its separate values? Like, how do we stretch a big number out to show exactly what it's made of on the inside? Well, that brings us straight to part 3, expanding numbers with values. Expanding a number is really just breaking it down to show the hidden math inside. Let's look at our friend 49,647 again. To stretch it apart, we pull down each digit and multiply it by its place value. So the 4 is pulled down as 4 times 10,000. The 9 becomes 9 times 1,000. The 6 is 6 times 100. The 4 is 4 times 10. And finally, the 7 is 7 times 1. When you write all of those out with plus signs in between them, boom, you have successfully written the number in expanded form using values. Excellent work so far. Now, are you ready to truly level up? Let's get into part 4, expanding with exponents. Did you know that scientists actually use this exact same math to measure the strength of massive earthquakes? It's true. They use powers of 10 to show how strong a quake is. And today,
we're going to learn how to use those same powers of 10 to expand our math numbers. But first things first, what exactly is an exponent or an index? Have you ever noticed that tiny number kind of floating at the top right corner of a bigger number in your math book? What is it actually trying to tell us?
Let's figure it out. Take a look here. We have 2 to the power of 5, which equals 32. The big number sitting firmly on the line, the 2, is called the base. And that tiny little number floating up at the top right, the 5, is called the index, or the exponent. But what is its actual job?
Well, the definition is beautifully simple. An exponent, or index, is just a small number that tells us how many times to multiply the base number by itself. So, in that last example, an index of 5 on a base of 2 just means we multiply 2 times 2 times 2 times 2 times 2. Let's really lock this definition into our memory for the exam.
Now, when we're dealing with really big numbers, we use powers of 10. Let's actually read these out loud together, just like we're in a classroom. 10 exponent 0 is 1. 10 exponent 1 is 10. 10 exponent 2 is 10 times 10, which is 100. 10 exponent 3 is 10 times 10 times 10, which is 1,000. And 10 exponent 4 is 10,000. Now, did you notice a trick here? The tiny exponent number tells you exactly how many zeros are going to be in your answer. 10 exponent 3 has 3 zeros. 10 exponent 4 has 4 zeros. Knowing this little trick is going to save you so much time on your tests.
All right, let's put this all together. Here is your primary 7 super skill challenge. How do we expand our number, 49,647, using these exponents we just learned about? We already expanded it using basic values a minute ago. Now let's upgrade it to those scientific powers of 10.
And here it is, the beautiful, final, expanded form using indices. Instead of writing out 10,000, we wrote 10 to the power of 4. So it's open bracket, 4 times 10 to the power of 4, close bracket, plus 9 times 10 to the power of 3, plus 6 times 10 to the power of 2, plus 4 times 10 to the power of 1, and finally plus 7 times 10 to the power of 0. And hey, always remember, 10 to the power of 0 is just 1. If you can write a number out like this, you have fully grasped a very advanced and highly rewarded topic for your exams.
Okay, I've got one final, exciting test for you before we wrap this up. Sometimes the examiner will try to be clever and give you the expanded form and ask you to work backward to find the original number. So look at this equation, open bracket, 7 times 10 to the power of 5, close bracket, plus 8 times 10 to the power of 4, plus 3 times 10 to the power of 2, plus 2 times 10 to the power of 1. What is the secret number hiding inside all those exponents? Take a second to work it out, and remember your zeros trick.
The secret number is 780,320. If you got that right, massive congratulations to you. Basically, you multiplied 7 by 100,000, 8 by 10,000, 3 by 100, and 2 by 10, and carefully added them all together. But did you notice there was no power of 3 in that equation? That means the thousands place had a 0. That is a classic examiner trick right there, and you just spotted it. Let's quickly review our final exam checklist to summarize the core skills we just mastered together in this explainer. 1. Always know the difference between the place value, which is the name, and the actual value, which is the math number. 2. Use your commas to group those huge numbers into threes so you can easily read and write them in words. 3. Know how to expand numbers by stretching out their basic values. And 4. Master your exponents using those powers of 10 just like a true scientist.
Think about everything you've learned today. So I want to leave you with this final question. Are you ready to tackle any 8-digit number on your primary 7 mathematics exam? I know for a fact you are. You've got the strategies, you know the tricks, and you understand the real value behind every single digit. Just keep practicing these steps, trust your commas, and use your powers of 10. Thank you so much for learning with me today in this explainer. Keep up the fantastic work and go crush those exams.